Alright, example 3, given AB congruent to CD and BC congruent to DA. We want to prove that DC is parallel to AB. So we want to prove that. Let's see if this comes out better. Ooh, I don't like that. Okay, so that's what we want to prove. All right, we're trying to show that those two lines are parallel, which means that we need to prove that one of those angle relationships is true. Corresponding angles are congruent, consecutive interior angles are supplementary, alternate interior angles are congruent. Those are going to be our main pieces that we're looking for. So we have a transversal. And we have the lines we want to show parallel. And so we want to demonstrate that these angles, which I'll call 1 and 2, are congruent. Angle 1 congruent to angle 2. These are alternate interiors. And if I can show that they are the same, then I will know that the lines are parallel. So how can I show that those angles are the same? CPCTC. And so I need to prove the two triangles are congruent using one of our methods. So just by looking at this picture, I do not have right triangles. They gave me information about two sides, so I know that my proof methods that involve two angles are out. I don't know anything about the angles, so I'm going to be looking for a third side, which if I look at this picture, oh, they share this common side AC. So in this video, we'll do the two column proof, and then in the next video, we will do the full proof. And again, you can fill in your given information as separate steps. However, these give us congruency statements between these sides right off the bat. So I don't really need to state them in two separate steps because they're not giving me anything new. They gave us those. So they gave us two sides. Again, we're looking for a third side. And remember, if you know where you're going with this, right, we're going to end this proof with DC parallel to AB. And we know that that's going to be because when alternate interior angles are congruent, then two lines cut by a transversal are parallel. So I know that's where I'm going. I know I'm going to prove angle 1 congruent to angle 2 by CPCTC. And I know that in order to use CPCTC, I'm going to have to prove two triangles congruent. So we're going to have to show that triangle ADC is congruent to triangle CBA. And we've chosen our method already by side, side, side. So notice I have the bottom of my proof done. I'm just trying to figure out where I get that third side from, which we've already identified in our picture is that AC is congruent to itself. So notice I'm putting the little S next to there because I have a congruency statement about a third side. We know that is reflexive property. Or a segment is congruent to itself. So I have three statements involving the congruence of sides, so I have enough information to prove the triangle is congruent by side, side, side. From my plan, I know that I am now allowed to talk about those corresponding angles in each triangle being congruent because they are parts of congruent triangles. And I know that I can now say that these two line segments are parallel because when the alternate interior angles are congruent, then the lines are parallel. And that is all for this proof.